Welcome everyone to this Bright Talk session, which is brought to you by the Storage Networking Industry Association. SNIA works to develop storage-related standards and has over 2,000 members from 185 companies. You can learn more about the work we do by going to snia.org/technical. My name is Rochelle Alders. I am part of the technology enabling team at Intel, and I've been involved with the SNIA for many years. I am the chair of the SNIA Scalable Storage Management Technical Work Group, which is where the SNIA Swordfish specification is being developed. I'm also the chair of the SNIA, I'm saying SNIA a lot, the SNIA Storage Management Initiative, which is sponsoring the work on the Swordfish specification. I'm here today to help facilitate this webcast and will also be a co-presenter. During this Bright Talk session, we will be talking about some of the emerging challenges managing the expanding interrelated types of fabrics used in today's data centers. We will also talk about some of the different how some of the different organizations are uniquely positioned and working to solve these problems, and how working together, these groups will be working together to accelerate the delivery of solutions. I will be co-presenting today with Phil Caton. Phil is a senior staff engineer at Intel Corporation with 25 years experience developing and researching non-volatile, local, and remote storage and fabric technologies, particularly NVMe, NVMe-oF, NVMe-MI, InfiniBand, and iWarp architectures, resulting in over 20 patents. Phil is also the vice chair of the OpenFabrics Alliance. If you have any questions you'd like to ask during the presentation, just type them into the Bright Talk Ask a Question box. We'll be collecting the questions and we'll answer them during a Q&A session following the presentation. We expect to have about 10 or 15 minutes for the Q&A portion. All right, with no further ado, I'll now turn things over to Phil to start us off with an overview of the data center landscape. Hang on just a second while we switch over to the presentation mode.
Okay, sure. Let's jump right in. So there are a large and increasing variety of fabrics. We have Ethernet and Fiber Channel, InfiniBand and PCIe. The list goes on, with new fabrics being architected and coming, such as Gen Z. Each fabric has its strengths, its own management tools. Each fabric has its own configuration mechanisms and interfaces. In addition, there are an increasing variety of interconnect capabilities, such as memory semantic fabrics, and an increasing variety of distributed compute and storage resources, such as fabric attached memory, storage class memory, accelerators of multiple types. To tie this together, there is an increasing variety of workloads, applications, of libraries and tool stacks that are increasingly incorporating these distributed computing capabilities and remote heterogeneous hardware. In other words, I'm talking about the transformation in diversity and distribution of compute and storage capabilities that workloads need to access. And we go to the next slide. So this creates some problems in manageability. Solution providers are faced with managing an increasingly diverse set of resources that need to be connected by and optimized for one or more fabrics to deliver complete solutions. And orchestration tools and workload managers, they don't deal well with multiple fabrics. And yet, there are no common fabric manager interfaces or fabric models available to link applications with distributed resources. So workloads are managed and optimized differently for each type of fabrics. And this is not a static environmental problem either. This is in an increasingly dynamic environment. Orchestration tools and workload managers, they have to account for changing resource needs, changing resource availability, and the paths and maybe even fabrics to get to them. So orchestration tools and workload managers will have to expand and become much more complex to accommodate all these distributed capabilities and resources. But at the moment, all such changes are likely to be very fabric specific. So every app and application librarian, library fabric provider, and workload manager, every composition service and resource manager, they'll need to make unique changes for every fabric they support. And this picture here is sort of a comical example of what it's going to start looking like. And so slide. But we can fix this. The industry, it needs interoperability through common interfaces to enable managers to efficiently connect workloads with resources in a dynamic environment. In other words, we need a good fabric services suite that's fabric agnostic and designed to stay current as new fabrics and new resources are developed. Really, we need a standards-based OpenFabrics management framework coupled with a standards-based ecosystem management solution. And that's what we're proposing, an open source solution to the M-to-N, if you will, fabric management problem. So without such an OpenFabrics management framework, every tool and every middleware library provider needs a unique call to specific fabric management stacks for each available fabric. However, with such an OpenFabrics management framework, everyone calls common fabric services to manipulate the Redfish fabric model. And the OpenFabrics management framework triggers fabric-specific providers to make actual fabric changes. Now, this talk is not intended to be a tutorial on the OpenFabrics management framework or Redfish or Swordfish models or use case analysis. Really, instead, it introduces how an expanded cooperation agreement between OFA and SNIA is working to ease the increasing fabric administration and orchestration problems. So let's go to a little bit, next slide, where the following slides are really a very quick overview into the goals of the OpenFabrics Management Framework, or OFMF project, and its basic architectural assumptions, its basic working strategy of the OFMF working group, and how Redfish and Swordfish are major partners of this solution. Currently, the OFMF working group is working through use cases associated with building clusters on various fabrics, such as Slingshot, InfiniBand, Gen Z, and also on deploying workloads from workload managers such as Slurm and Kubernetes. Basically, the OpenFabrics Management Framework working group, we're working towards a list of API calls needed northbound of the OFMF and how they have to look to fabric-specific providers. So at the same time, the Redfish models are being defined and refined in parallel with the required services. And so if I just go through a kind of a small laundry list of things that are either being looked at or going to be looked at, we have control services for discovery and inventory. We have communication services for connection management and addressing, managing fabric addresses. Concentrating now on partitioning services, zones and subnets and VLANs and connections for like permitted paths. Also messaging services for queues and contexts, events and errors, and atomics and synchronizations, and always looking towards security. What security is needed at what stage, for instance, subfabrics, which provide exclusionary access security. And with others to come, concentrating on workload management. So if we go to the next slide, this is, sorry that these for people who don't care for builds, this slide builds on the block diagram. Sort of the architecture of the OFMF for client to resource administration paths. Again, it's just a high-level in-process block diagram architecture. Certainly not set in stone. But here on the left side, as shown, it includes the user and administration and orchestration and automation domains. And then on the right side, you'll see the hardware that makes up the fabric and provides access to resources that are accessed on those fabrics. And then in the middle, you'll see a representation of functional blocks that make up OpenFabrics Management Framework. On the left side, you'll see the various workload managers, applications and libraries and resource managers. They're represented here. They're all clients of the framework, you see. But inside the OFMF, there is the state of all the fabrics being represented to the clients is represented using the fabric, the Redfish fabric model. And on the right board of the OFMF, there are fabric-specific providers for each of the fabrics for which the OFMF is supplying common services. And each provider may have its own native model to its specific fabric. So any entity, such as a software tool or an administration GUI or a shell script, they may need to create a virtual platform or cluster or partition, job queue or something, whatever that particular entity calls this set of resources that are connected together to enable workloads to execute while being isolated from other jobs. Now, this calls into something I have to mention. Entities need a common taxonomy to describe the resources needed and how connections amongst the sets must behave. So what we're really proposing is to use DMTF's Redfish standards to model the fabric and its resources, and to provide RESTful interfaces through which the entities on the left can learn about modeled resources and create such a set of fabric resources. Now, going on with the Redfish and taxonomy, Redfish currently has an object called a zone, and it contains a list of fabric endpoints which may be connected to each other. So zones can be used to enumerate the members of a VLANs or the resources of a virtual platform. The framework will update the Redfish model for given fabrics and exchange the appropriate details with the fabric-specific providers. And the providers are responsible for updating the native models that they maintain for their fabric and to issue the appropriate traffic to the fabric hardware. So it's important to note here that the administration tools are not the only clients of this OpenFabrics Management Framework services. You have applications and resource managers. They need runtime support in the form of creating and registering and attaching and freeing these shared memory regions. And operating systems and virtual machine managers need interfaces to request the initial, the boot time, resource allocations, and runtime changes, as well as authentication and events and logging services. And this really brings us to the next slide, where we discuss integration of the OpenFabrics Management Framework into a standards-based enterprise and data center ecosystem. And this brings it into Rochelle and that, and also our partnership between SNIA and OFA.
Thanks, Phil. All right, so let's jump in a little bit. We've talked a lot, and Phil has mentioned a lot about, Redfish and Swordfish, but let's talk a little bit about what those things are. Let's back up a little bit. So what are Redfish and Swordfish? Well, let's start here with the basics of what is Redfish. Redfish is built by the DMTF. It's a specification that covers server, data center, and fabric management. It started with basic server management and has been growing. It's a REST-based API with JSON payloads. You can have multiple different types of schema that you work with based on a little bit of your personal preference or what works best with your environment. You can use CSDL, JSON, YAML schema, but you're basically going to be dealing with a REST API and JSON payloads. There's also some additional structure provided by the OData annotations, just to provide a little clarity in terms of what type of JSON payload and how everything is laid out. I'll go into that in a little bit more detail soon. So what is Swordfish? Well, Swordfish is not separate. It is not a distinct thing from Redfish. It is simply these storage-specific extensions to Redfish. But it's built by SNIA because SNIA is where the storage experts are. So SNIA basically contains all of the storage extensions for Redfish. It covers a lot of these use cases. It covers block, file, and object storage, where Redfish only has very, very simple, some simple direct attach cases. Swordfish covers the advanced direct attach cases. It covers traditional storage, domain, converged environments. We have support for functionality, including class of service, and then we lead the Alliance partnerships to bring together additional new technologies, such as support for NVMe and NVMe over fabrics. So SNIA, DMTF, and NVM Express have partnered through an alliance agreement in the past 2 years to bring NVMe and NVMe-oF capabilities into Redfish and Swordfish and provide a comprehensive solution for managing those environments as well. All right, so what does that actually look like? How is it structured? And the basic Redfish hierarchy is fairly straightforward. There's a couple of different ways you can structure things in REST, but we've chosen basically a fixed URI structure. So everything you'll find in the Redfish hierarchy is under/redfish/v1. Once you get past that, there's a couple of different places things are broken out. The first is the systems themselves are largely broken out into a logical view and a physical view. And then there's multiple starting points based on the type of system you're talking about. This shows the representation for a server, so a server would be broken out with its physical view under/systems and its logical view under/systems and its physical view under/chassis. There's also a representation for where it's management, whether it's embedded physical management or logical management is under/manager. There's a set of services that are provided across the board. These include task management, event services, security, account sessions, all those different kinds of services that also are available from what we call the service root, which is the /redfish/v1. So you can see from this example that there's basically a structure that we call, if you hear me use the word collection or a resource, a collection is basically, think of it as an array of objects. /systems is the array, and then you'll see a singleton here. And then inside these, you'll see that pattern repeated for all of the things you'd expect to see in a system. So in a system, you'd expect to see processors, some storage like, attached, some direct attached drives, for example, Ethernet interfaces. And then similarly, when you're modeling the physical infrastructure, you might see, again, where are the drives? What do the chassis actually look like, which is why this is in chassis, and additional information modeling about that, power, thermal information. And similarly, under managers, this server view, this manager really is talking about also representing its BMC environment. So there's some additional information there, but you'll see, logs around management and network protocols. How do I access the manager? As some nice generic level information. All right, so what does it mean to add storage extensions? Well, you can see there's a little bit of storage here, but that's fairly lightweight from a server perspective. When we start to add storage from the sake of managing the storage, we get to a little bit, same hierarchy, but a little bit more complicated capabilities, definitely much more complex. You can still have a very simple system, or you can add a lot of complexity to it. As you start to scale up and scale out in your environment, either one, you end up needing more complex structures to be able to manage that. So we basically take this same structure. You can see here, we've got that logical representation up here, which is now under /storage, and then the physical representation, which stays under /chassis. So you can see the difference here that in the servers, you had /servers/storage. That just showed the storage attached to those servers. In this case, we have /storage, which is, you can use this model now to reflect, standalone storage or, storage that's attached to systems. But basically, this is a place you can go to find the storage attached on any system. So I mentioned scale up and scale out. Some of those things you need here is, instead of just storage volumes and drives, you may need pools, disk groups, whatever your favorite flavor of name is to call these things. But this is basically additional levels of abstraction. So you have all of these base components here, your volumes or your file systems. This view is really just block. I have similar diagrams for a file view, but this is a block view. Storage pools, which are basically aggregations of underlying capacity. And in this case, this shows it using drives. We could show this built out of memory as well, or pools of pools or pools of volumes. It's a very flexible structure. But ultimately, you get to the point where you have pools, and these volumes are created out of pools, and that's what's used and mapped and presented up. Similarly, on the chassis, you see the same thing you saw in the server picture, where chassis are where you see your physical drive enclosures, and then your drives are actually used by your logical entities. There's some other pieces which I didn't mention here when I talked about the services earlier, called registries. These registries include information about, just advertising. These are used for, in this case, this is actually used to advertise features. So you can actually see, the client can actually see what features are actually reported in kind of user-friendly names. And there's other uses for the registries as well, such as authorization and security and some other mechanisms, messaging, standardized messaging, and there's quite a few others. Okay, so one of the other things I put on here just to kind of highlight, I talked real briefly about, mapping and that we've been working with the NVMe, NVM Express group in order to bring Redfish, Swordfish, and NVMe together. One of the things we did here was basically said, all of these boxes on the screen are really existing storage constructs that have been around for a long time. NVMe has some new constructs. How do we bring those new constructs in to the Redfish and Swordfish hierarchy? So we did a mapping and have a lot of comprehensive documentation that talks about which objects map. We've extended the properties, and we basically made a comprehensive management guide and a mapping document that shows how to translate between the two specifications. Why am I talking about that here? Well, I'm talking about that here because one of the pieces of that is not just NVMe for an NVMe device. It's also looking at how we do that for NVMe-oF or over fabrics. And this is a precursor to some of this other work that Phil started talking about with managing the fabrics in general. So let me get into that a little bit. So when we started adding NVMe-oF to that same hierarchy, that same mapping that I just talked about here, this is what it looks like. This in addition to /storage or /server at this, hanging off the service route, we also have /fabrics. Now /fabrics the fabrics collection has two different things you can do with it. The first one, and this is what's reflected here, is showing access rights. You can actually show connectivity and access rights, both reflected under the fabrics. The connectivity uses this notion of connections and then endpoints and zones. Endpoints are ways to reflect the abstraction of the systems. And then connections and zones are ways to say connections show access rights and zones show inclusion or exclusion. And then that is basically included into this whole picture to show what we've done with the NVMe-oF environment. If we talk a little bit more about what we're trying to do here, the other view is connectivity. So if we talk about fabrics, fabrics also then includes what you'd expect to see, which is we have switches that also have endpoints and zones. So the endpoints and zones do the exact same thing in the general connectivity portion of the fabric model, where the switches represent the infrastructure. Okay, and so why am I going through this? Well, I'm going through this because as we talk about how we bring Redfish, Swordfish, and Universal Fabric Management together, we actually bring a lot of the work we're highlighting here is actually bringing this OpenFabrics management framework and mapping it directly to this fabrics model, both this one and the one on the last page. It just gets really busy trying to put all these boxes on the same slide. But basically mapping that the ability of the OpenFabrics management framework and that notion of, and the intelligence there of all of those different types of fabrics into this fabric model, and leveraging the work that's already in place of storage and storage fabric utilization, as well as general purpose fabric and fabric management utilization. So this is really kind of what I was highlighting there. When we start bringing all of those pieces together, you've got all of this bottom portion of this picture, the OpenFabrics management framework, which is working not only on this base infrastructure and device level management, managing the fabric itself, but it provides, and then plugging that up into ecosystem management and ecosystem enablement. So you've got servers, storage, and then now the fabric management in here as well through this. And then that enables the orchestration tools. These can be things in the open source space like SODA and others up here. And then we get this base ecosystem enablement down, and you can work across all these different kinds of fabric surfaces. We put this entire thing together. The client interface then becomes nice and uniform. So just like with other types of server and storage technologies, it doesn't matter what's on the bottom side from the client. These plug into all sorts of different things. In this case, the fabric management portion then starts to plug into the Open Fabric Management Framework. So that's a lot of what we're looking at here, initially doing a lot of the pure ecosystem and fabric enablement, but also providing then an infrastructure and a framework to start working on and enabling the Open Fabric Management Framework to work on more value add automation and orchestration capabilities itself. All right, so with that overview, hopefully that provides a little bit of clarity both on how we're trying to, what we're trying to do and how we're trying to do it. But let's talk about timelines. It seems like a pretty ambitious set of work. How are we going to do that? Well, one of the reasons I mentioned a little bit about the Redfish and Swordfish and NVMe Alliance is we view alliances as a very powerful tool within SNIA. And so we're very, very proud to announce and talk about the work that Swordfish and the OpenFabrics Alliance are doing together. Through alliance agreements, we can bring technical teams from various organizations together to align existing work instead of creating another wheel and duplicating effort. So if you look here, here's kind of where a lot of existing work stands, right? We've talked about that server and fabric management that already exists within Redfish. We talked about the storage expertise within Swordfish, and now we have the OpenFabrics Alliance that's got a lot of this expertise in open fabrics management. So this is where we can bring all of these things together. SNIA brings the storage and storage fabric management and domain expertise, and OFA, and because Swordfish already extends Redfish, it has that storage fabric management capability. And then OFA can help accelerate the development of adoption of advanced fabrics. So what we can do is basically leverage the strengths and core competencies of both of those organizations by working together. So we're very proud to announce that tomorrow we will be, and tomorrow you'll see a press release on this. SNIA and OFA have signed an expanded alliance agreement to focus on this activity. The goal of this is for each organization to create new content in their area of domain expertise as needed. And instead of having additional new overlapping content developed, we focus in on the area of overlap and ensure that that is really where the bulk of the effort is going forward. All right, Phil?
That leads us to, that leads us to the planned work item. So with this cooperation, expanded agreement between SNIA and OFA, we have a lot of work that we can do and a lot of expertise here. So the more client use cases we can explore, the greater understanding we'll have with the common OFMF services that are useful to the industry. And as such, we need provider-driven use case input. We need to know and learn better about what services can the OFMF and other providers, such as Fabric, offer providers. We can learn how does a Fabric provider alter switch settings and what happens when new zones are created. And we can learn, what happens and what should the OFMF and Redfish, Swordfish models apply to a given Fabric and provider. We need to step through all the use cases for available fabrics to make sure the Redfish Fabric extensions are flexible enough to meet all the needs, or if extensions are needed or to be modified, or if new extensions are needed. So what we're doing is really working together to create this an ability for an expanded dynamic ecosystem where new things come all the time and new connections are needed. And we're kind of hoping to have a proof of concept demo for later this year.
Right. One of the things we're looking at here is, as the OFA is developing all of these great new use cases, we can use traditional Redfish and Swordfish accelerated development tools such as mockups to validate those use cases, help identify very quickly areas where we need to expand, and also use some of the Redfish and Swordfish ecosystem and open source tools to help with the POC that Phil just described. All right, so thanks for, I think that covers a whole lot of the material we wanted to cover today. At this point, I think we'll transition over and take just a couple of questions. Let's see, I see a few teed up into the Q&A section. I will remind folks to hit the Ask a Question button at the bottom of your work area, and we will take one of the first questions here. All right, Phil, I will ask you to take this one. You've highlighted workload management as a key issue in Fabrics, but you're not addressing it here. Can you comment on that?
Sure. Can you go back to slide 13? Sure. So the talk on universal fabrics management coupled with workload management, the main focus here is that workloads are increasingly needed to be aware of and be connected to distributed resources on a multitude of fabrics. And so really the focus here is the creation of a common set of APIs that can describe fabrics so that workload managers and orchestration engines know how to get from workload to resource without having to go through multiple workload managers and multiple sets of APIs, and it will enable a more seamless environment. So that's my answer there. Rochelle, did you have a point?
Yeah, I think the one thing I would also add to that is it's a matter of priorities. We work on getting the base instrumentation, base management done first, so then we can move on to the value add.
Right, and it's very analogous to you get the plumbing set up before you go on from there.
Yes, absolutely. All right, this is a next question. You've been talking about an alliance agreement here. This is all describing a two-way alliance agreement between SNIA and OFA. Since this work so heavily involves the DMTF, why isn't this a three-way work agreement? That is an excellent question, and that is one of the absolute next things that we will be working on now that we have this two-way alliance agreement. We will actually be working to develop a three-way agreement, but this allows us to get started and develop get the work going on the storage specific use cases. We're absolutely able to start identifying the areas where we will also need the enhancements in the DMTF space while we get that alliance agreement in place. But that work to develop that alliance agreement has actually already started.
And I'd like to add, so there's already agreements between OFA and SNIA and DMTF and OFA, and I assume OFA, SNIA and DMTF. This is an expansion of those agreements to include this particular area of OpenFabrics Management Framework. And so we started with the agreement between OFA and SNIA, and we're expanding it to include this model. And then the next step is to bring in DMTF.
Perfect. Thank you, Phil. All right. Let's see. Next question. All right. This one's going to be for both of us. Let's see. You don't include NVMe-oF in your diagrams. Is that an area you're trying to address? So let me give you the quick answer, and then Phil will give you the longer answer. What we're trying to do here is we're covering the F part of NVMe-oF. We don't focus on the NVMe part in this section of work. Phil?
Yeah, so right, and that's very well said. As I said earlier, we're concentrating on the plumbing to connect workloads with resources, and NVMe or Fabrics is a storage resource, a remote storage resource, and that is something that needs to be addressed and will be addressed. But plumbing first.
All right. Oh, a great question. Here's like our next favorite question. This work looks like a lot of great stuff. How do we get involved? Our one last slide. Thank you for watching. I'll just jump right to that. How do we get involved? Well, there's a lot of ways to get involved here. So one of the things we haven't really talked about, we've glossed over briefly, is which groups in which organizations are working on things. So within SNIA, we have the Scalable Storage Management Technical Work Group that is working on developing SNIA Swordfish. We also have the SMI, which is the management initiative, the storage management initiative, and that group works on marketing and promotion. So if you're interested in one of those two areas, we have contact information for there. You can find all of that at snia.org/swordfish. You can find pointers to those. You can also find ways to join here on the screen. I'll get back to those in a second. On the Open Fabric Management Framework, this is being done out of the really, really cryptic acronym OFMFWG, the OFMF working group within the OpenFabrics Alliance.
Yeah, and then OFA is an open organization. It's quite easy to get involved.
Yes, thank you. So if you are a member of SNIA, you are welcome to join the SNIA Swordfish and work or join the organization. If you've not worked with the organization, you can ask and answer questions also at swordfishforum.com. With the OpenFabrics Alliance, you can join the organization, or you can simply join and look at what's going on in the working group, because everything is done in open source and everything is also done in open meetings. There's also a pointer here to DMTF Redfish for any additional information. Similarly to SNIA, if you were interested in joining and working on Redfish, you can go to dmtf.org and look up information. You will basically need to go to dmtf.org, join DMTF, and then join the Redfish Forum. Let's see. Next question. Can you give us more detail on the Fabric administration services? Phil?
Sure. So that's a big question, and there's a lot of sub questions there, I'm sure, and a lot of nuance. But as you saw, if you go back to the example slide, we're working through what services are necessary, what services are needed for the various.
There we go.
Sorry, there you go. So we're looking for what services are needed for what providers, and how to connect them between, again, the orchestration engines and the actual hardware management. And so this is the list that we're working off of, and we're working currently mostly on the partitioning services. I really invite you to come to the meetings we had. They're actually 2 hours a week on Wednesdays and Fridays for an hour each, and bring in specific questions and bring in what you might like to see, where we're missing, or find if there's a certain expertise that you can bring to it to help out the project. That would be great. We certainly invite people to get involved.
All right, and with that, I think we're getting close to end of time here. I would ask everyone to please give us a 5-star review. Appreciate it. And if you have any additions, questions, follow-up questions, please address them to storagemanagement@snia.org, and we will route them appropriately.
Or go to the OFMF and attend the work group and help out.
All right. Thank you, everyone. Have a great day.